In the first video series on IAQ Basics, we learned that people in buildings exhale carbon dioxide, or CO2, which raises the concentration indoors. Continuous monitoring of CO2 levels is recommended to quickly detect ventilation problems. Monitoring CO2 levels is a useful and convenient way to monitor ventilation, particularly in densely occupied spaces. You can see here how CO2 concentrations change throughout the day in an example classroom. When the classroom is empty at the beginning of the day, CO2 levels are about 400 parts per million, or ppm, which is approximately the concentration of outdoor air. When students come in, the level of CO2 will rise. In a well-ventilated classroom, it will generally level off below 1,100 parts per million. In a classroom with ventilation problems, it will keep climbing, sometimes as high as 3,000 parts per million. We recommend that CO2 sensors used for monitoring buildings meet the following specifications. The CO2 sensor should have a range of 400 to 2,000 parts per million or greater and be accurate to within 75 parts per million or better at a reading of 1,000 parts per million. The sensors should be permanently installed for long-term monitoring. They should be mounted in the breathing zone, approximately 3 to 6 feet above the floor and away from doors and operable windows. For transparency, the sensor should display the CO2 value on the device, or the data should be made available to the occupants in some format, for example, through a website or dashboard. The sensor should have an indicator, such as a colored light, when the CO2 level has exceeded 1,100 parts per million. Finally, the sensor should maintain a record of the previous data or be connected to a building management system that is logging the CO2 levels. There are many options for CO2 sensors available on the market. We've evaluated over 15 models of CO2 sensors on the UC Davis Empower Procurement website. This website allows you to compare different models side by side, including manufacturer specifications and accuracy testing results. The reviews also include our testers' feedback on installation and operation of the sensors and their integration and reporting capabilities. There is also general guidance that can help you select sensors for your application. Visit this website at energyproductevaluations.org. Finally, let's talk about how to interpret CO2 sensor data. The CO2 level is an indicator of how well the ventilation system is working. You'll want to review data for times that the building is at peak occupancy and compare CO2 levels to a threshold of 1,100 parts per million. Spaces that have CO2 levels that frequently exceed 1,100 parts per million are likely to be underventilated and may be a cause for concern. While it's generally less so a problem, you'll also want to look for daily peak CO2 levels that are consistently low, for example, below 800 parts per million. If your buildings have a low occupant density, then low CO2 levels are expected. However, in densely occupied buildings, low CO2 levels could indicate too much ventilation, which may consume excess energy and expose occupants to more outdoor pollution. Note, however, that when outdoor air temperatures are cool, low CO2 levels may be explained by an economizer providing 100% outdoor air for cooling to save energy. When your CO2 sensors indicate a problem with the ventilation, you need to conduct an inspection as described in the previous module. Document your findings and seek assistance from a certified technician for a ventilation system adjustment or repair.